Space is big, really big. When we look up at the night sky, we see just a tiny fraction of what's out there. The universe is vast and filled with wonders beyond our imagination. It's full of galaxies, huge groups of stars like our own Milky Way. Each galaxy contains millions if not billions of stars, along with planets, moons, and other celestial objects. These galaxies come in various shapes and sizes, from spiral and elliptical to irregular forms. Our galaxy has billions of stars, and there are billions of galaxies out there. The sheer number of stars and galaxies is almost incomprehensible. Each star could potentially host its own system of planets, some of which might even harbor life. Can you imagine that? It's mind-boggling. The more we learn about the universe, the more we realize how small we are in the grand scheme of things. Yet, this vastness also fills us with a sense of wonder and curiosity. We study these distant galaxies to learn about the universe and our place in it. Through powerful telescopes and advanced technology, astronomers can observe galaxies that are millions or even billions of light years away. These observations help us understand the history and evolution of the cosmos. Imagine looking at the night sky and seeing a faint smudge of light. That tiny speck could be an entire galaxy, filled with countless stars and planets. It's incredible to think that what appears as a small dot to us is actually a massive collection of celestial bodies. That's what many distant galaxies look like to us. They are so far away that even the most powerful telescopes can only capture them as faint glimmers in the vast darkness of space. They are so far away that their light takes billions of years to reach Earth. When we observe these galaxies, we are actually seeing them as they were billions of years ago. This means we are looking back in time, witnessing the universe as it was in its earlier stages. Studying them is like looking back in time. By analyzing the light from these distant galaxies, scientists can learn about the conditions and events that occurred in the early universe. This helps us piece together the story of how everything we see today came to be. We can learn about the early universe and how galaxies form and evolve. By understanding the processes that shape the cosmos, we gain insights into the fundamental laws of nature and our own origins. The study of galaxies is not just about looking outward, but also about looking inward, to understand our place in this vast, incredible universe. How do we study things so far away? The universe is vast, and many of its wonders are light years away from us. Yet we have found ways to explore these distant realms. We use amazing tools like telescopes and satellites. These instruments are marvels of modern engineering, designed to capture the faintest glimmers of light from the farthest reaches of space. These are like our eyes in the sky, allowing us to see things we could never see with our naked eyes. Positioned high above the Earth's atmosphere, they avoid the distortions caused by air and light pollution, providing us with crystal-clear views of the cosmos. The Hubble Space Telescope, for example, has revolutionized our understanding of the universe. Launched in 1990, it has captured breathtaking images of galaxies, nebulae, and star clusters, offering insights into the birth and death of stars, the formation of planets, and the expansion of the universe. Satellites like the James Webb Space Telescope are even more powerful. Set to launch in the near future, it promises to delve even deeper into the mysteries of the cosmos, with its advanced infrared capabilities, allowing it to peer through cosmic dust and uncover hidden structures in the universe. They orbit Earth and capture even more detailed images of distant galaxies. By studying these images, scientists can learn about the formation and evolution of galaxies, the behavior of black holes, and the nature of dark matter and dark energy. These telescopes detect different kinds of light, including visible light, infrared light, and X-rays. Each type of light reveals different aspects of celestial objects, from their temperature and composition to their motion and magnetic fields. Each type of light tells us something different about the objects we observe. By combining data from multiple wavelengths, astronomers can create a more complete picture of the universe, uncovering details that would be invisible to the human eye alone. This multi-wavelength approach allows us to study the universe in unprecedented detail, revealing its beauty and complexity in ways we never thought possible. One way we study distant galaxies is by looking at their light. Light might seem simple, but it carries a lot of information. It's like a cosmic fingerprint. By analyzing the light from galaxies, we can learn about their composition, temperature, and even their movement. This analysis is called spectroscopy. It's like passing sunlight through a prism to see the rainbow of colors. Each color represents a different wavelength of light. By studying these wavelengths, we can identify the elements present in the galaxy, like hydrogen, helium, and even heavier elements. Another important concept is redshift. Imagine the sound of a car speeding away. The sound waves stretch out, making the pitch lower. Similarly, light waves from distant galaxies also stretch as they travel through space. This stretching makes the light appear redder, hence the term redshift. Redshift tells us how fast a galaxy is moving away from us. The greater the redshift, the faster the galaxy is receding. This discovery was crucial in understanding that the universe is expanding, a groundbreaking finding that changed our view of the cosmos. Section 5: Galaxies far, far away. Using these techniques, we have discovered some truly amazing things. We've found galaxies so far away that their light has been traveling towards us for almost the entire age of the universe. That's about 13.8 billion years. These early galaxies are much smaller and less structured than our own Milky Way. We've also observed galaxies colliding and merging, a spectacular cosmic dance that can trigger the formation of new stars. These observations help us understand how galaxies evolve and interact with their surroundings. Section 6: Cosmic Time Machines. Studying distant galaxies is like looking back in time. Because light takes time to travel, the light we see from a galaxy billions of light years away left that galaxy billions of years ago. It's like receiving a postcard from the past. By observing these distant galaxies, we can see how they looked when the universe was much younger. This helps us piece together the history of the universe and understand how galaxies formed and evolved over time. Section 7: The Expanding Universe. One of the most important discoveries made through the study of distant galaxies is that the universe is expanding. This means that space itself is stretching, carrying galaxies along with it. Imagine baking a loaf of raisin bread. As the bread rises, the raisins, representing galaxies, move farther apart from each other. That's similar to what's happening in the universe. The farther away a galaxy is from us, the faster it appears to be moving away. Section 8: Dark Matter and Dark Energy. Our observations of distant galaxies have also led to the discovery of two mysterious phenomena: dark matter and dark energy. These two components make up about 95% of the universe, yet they remain some of the biggest mysteries in modern astrophysics. Dark matter is an invisible substance that holds galaxies together. It doesn't emit, absorb, or reflect light, making it completely invisible and detectable only through its gravitational effects. Scientists believe that dark matter acts as a cosmic glue, binding galaxies and galaxy clusters together. We can't see it directly, but we know it's there because of its gravitational effects. For instance, gravitational lensing, where light from distant objects is bent around massive objects, provides evidence of dark matter's presence. Without dark matter, galaxies would not have enough mass to hold themselves together. Dark energy, on the other hand, is a mysterious force that is causing the expansion of the universe to accelerate. Unlike dark matter, dark energy is thought to be uniformly distributed throughout space and time. It acts as a repulsive force, counteracting the pull of gravity. It's like an anti-gravity force, pushing everything apart. This accelerated expansion was first observed in the late 1990s through the study of distant supernovae, which appeared dimmer than expected, indicating they were farther away than previously thought. These discoveries have opened up entirely new fields of research in astrophysics and cosmology. Researchers are now developing new theories and conducting experiments to better understand these enigmatic components of our universe. The study of dark matter and dark energy not only helps us comprehend the cosmos, but also challenges our understanding of fundamental physics. Section 9: The Quest Continues. The exploration of distant galaxies is a journey into the unknown. Every new discovery raises more questions and pushes the boundaries of our understanding. We continue to build bigger and better telescopes, develop new technologies, and refine our theories to unravel the mysteries of the universe. The study of distant galaxies is not just about understanding what's out there, it's about understanding our place in the cosmos, and appreciating the vastness and complexity of the universe we live in.